we'll practice drawing Lewis dot structures of atoms. First, we'll start off with sodium. We'll write Na, its element symbol, and then depict just its valence electrons with the Lewis dot symbol. So we find sodium in the first column on the periodic table, so it has one outer valence electron, just like we saw in the video. It only had one in its outermost shell. Now, chlorine had 7 valence electrons in its outermost shell, and it's in that 7th main group. And so we're going to draw 1 on each side. So we get to 4. Now we're going to start doubling them up. 5, 6, 7 valence electrons. Putting 1 on each side is helpful before doubling up because then we get the right number of paired and unpaired electrons when we're done. We'll see with oxygen. It only has 6 valence electrons. It's in the 6th main group on the periodic table. And so if we put 1 on each side, 4, then we start doubling up 5, 6, we end up with 2 pairs of electrons. So those 4 electrons that are in pairs, and then we end up with those 2 unpaired electrons, just like we're supposed to. Now we'll draw a Lewis dot diagram of sodium chloride. First, we'll redraw our sodium with its 1 valence electron. Then we'll redraw our chlorine with its 7 valence electrons, just like we drew on the last slide. And we want to depict what we were seeing in the video. So we were seeing sodium give up 1 electron over to this spot that's open here in chlorine. Now what's formed, we'll put as a product here, we'll put Na, and it's got an overall positive charge. And it's right next to chlorine. It's attracted to chlorine where it gave its electron. And chlorine has an overall negative charge. Chlorine gained an electron, becomes negatively charged. Sodium gives up an electron, still has all its protons, so it's positively charged. This is how I like to remember that about sodium. Sodium gives up an electron. I lost an electron. I lost an electron. Are you sure? I'm positive. So just a little hint to help you remember. I lost an electron. Lost an electron. Are you sure? I'm positive. So sodium is positive that it lost an electron, and it's positively charged. So hopefully that helps you. And when we go to rewrite the formula, well, this formula is just NaCl because there's 1 of each. 1 sodium, 1 chlorine. This is an example of ionic bonding between sodium and oxygen. So our summary of steps is that we're going to start by drawing the Lewis dot structure of each atom in this ionic compound. So we're going to draw the Lewis dot structure of sodium by writing Na, its element symbol, and its 1 valence electron. Oxygen will write an element symbol of O, and we'll show its 6 valence electrons. We'll draw 1 on each side here until we get to 4 of them, and then double them up 5 and 6. Then we'll use arrows to show electron transfer. So we'll show the metal sodium giving up an electron right here to the nonmetal oxygen. But at this point, sodium's given up all of its outer valence shell electrons. It just had 1. But oxygen needs 1 more electron. It has 1 more space here that needs another electron. We only have sodium and oxygen to work with in this problem, so we have to add another sodium atom. So what we'll do is draw in another sodium atom, and we'll depict it giving up its valence electron to this other spot on oxygen that needs to gain an electron. So in our final compound, each Na is positively charged because each sodium loses an electron. And the oxygen atom started off with 6 valence electrons, but it got 1 from each sodium, and now it has a charge of 2 minus. And the final formula is going to be that we have 2 sodium atoms for every 1 oxygen atom, or Na2O.